Hello friends, today we will discuss about the optical properties of colloids. Basically, colloids can be identified by its three characteristic properties, which are optical properties, kinetic properties and electrical properties. We will discuss each of them one by one. So first one is optical properties. So as its name indicates, optical properties are those which are visible to us. In this, I will explain two optical effects. First, Tyndall effect and scattering of light. Among various properties of colloidal sol, one is Tyndall effect. The Tyndall effect was first described by physicist John Tyndall in 19th century. It states that when a beam of light is passed through a colloidal sol, a visible cone is observed due to scattering of light. This visible cone is known as the Tyndall cone. This effect is not visible in true solutions due to particles of size less than 1 nanometer, which are not able to scatter the beam of light. But this effect is visible under two conditions only. First, when it is observed against a dark background, and second, when a beam of light is at right angle to the plane of observation. Although the particles cannot be seen directly, only the bright spots corresponding to particles can be observed. Now, what is scattering of light? Scattering means spreading after breakdown. That is, when a beam of light or a ray of light strikes with a particle of colloidal size, it will break down in smaller rays and spread in the surroundings. Some points to ponder about scattering of light are: it can be described in terms of turbidity, that is, ratio of intensity of scattered light by intensity of incident light when it is passed through 1 centimeter of solution. Intensity of scattered light is difference in the intensity of incident light before and after passing through the solution. Second, effect of wavelength. It should be remembered that the intensity of scattered light is inversely proportional to the fourth power of wavelength. That is, the lesser the wavelength of incident light, the more will be scattering of it. These effects help in determining the size, shape and molecular weight of colloids. Size is determined by using electron microscope. It uses beam of high energy electrons as a radiation source, which have wavelength in the region of 0.01 nanometer, that is 0.1 angstrom. The smaller the wavelength of radiation used, the more will be the resolving power of the electron microscope. Shape of particles is determined by angle of scattered light. Uniformity of angle is observed when a symmetric molecule is present, while asymmetric molecule scatters light in various angles. Similarly, the molecular weight is determined by the turbidity of the colloid sol, as turbidity is directly proportional to the molecular weight of the colloid. So, this is all about optical properties of colloids. Thank you.